Good morning, guys. Bright and early, okay, not bright, but dark and early this morning. I'm out here talking to you about wind. We're going to talk about wind today. We talked about wind before when Hurricane Laura was coming in and pounded on the coast of Louisiana. Now we've got another hurricane, Hurricane Sally. Hurricane Sally is coming to Louisiana this morning. Right now it's pounding in with about 85-mile-per-hour winds. And remember, anything that's over 74 miles per hour counts as a hurricane. Here's a question: are there hurricanes on other planets? What do you think? Now think about, what does it take to have a hurricane? Hurricane has to have warm ocean water to feed that, with the evaporation releasing the heat and driving that current of rising air. So if it doesn't have that warm water, it's not going to have a hurricane. And Earth is the only planet that has warm ocean water. So no other planets have hurricanes, but they do have wind. So we're going to compare the different wind speeds on different planets. And I set up a little demonstration where I'm going to have a leaf flow across the same distance that it would go. Mars has a wind speed of 60 to 70 miles per hour. Not very fast. That's the top wind speed for anything registered on the planet. It's enough that there's a little bit of an atmosphere, enough to have dust storms, but not crazy. Earth has wind speeds up to 240, 250 miles an hour. That is significant. That's really damaging. As we've seen with hurricanes, 250 miles per hour is a devastating, wipe out everything that's there type of hurricane. Venus also has winds of 250 miles per hour. Jupiter also has winds of 250 miles per hour. Uranus has winds of 560 miles per hour. Saturn gets interesting, 1,100 miles per hour. Neptune's winds are 1,600 miles per hour. Coming to our last planet to talk about, Mercury is our smallest planet. Tiny little thing, no atmosphere to speak of. So you would think that, well, it's got no atmosphere, it doesn't have any air to blow around, so there wouldn't be any wind. And on the surface, you're right. The atmosphere that they have, particles of gases, they're kind of stuck to the surface as just kind of an extra layer. It's not even what we'd call an atmosphere. But they do have wind. They get the solar wind. The solar wind can go 1,000,000 miles an hour. Whew! The solar wind is a lot like the wind we have on Earth in just a larger scale. All of the heat that's being produced by the sun pushes all of their gases out further and further apart, to the point that they escape the gravity of the sun and go flying through the solar system. Those gases are bits of tiny particles, atoms, and then pieces of atoms, which we haven't even talked about yet, that will come blowing past a planet. And planets like Mercury that don't have an atmosphere, don't have a magnetic field, don't have anything to protect them from this solar wind. Earth is protected from this solar wind because we have a really good magnetic field. But we'll talk about that another time. So what does it take to make wind? It takes uneven heat. Uneven heating on one part of the land or the water or wherever it happens to be. If one part is heating up more than the other, it's expanding, it's rising, and it's pushing to the sides. That pushing to the side is where we get our wind. Expanding, rising, pushing to the side, and that pushes other air out of the way. I'm gonna make myself some breakfast now. I'm gonna make some oatmeal, but I'm gonna make it in a special way to show uneven heat. I've got my pan of water. The burner is gonna be just on this side of the pan. Put some oatmeal in and we can see how it would move around. So we're watching this, and you should be seeing that one side of the pan is heating up and it's getting excited. That thermal energy is transferring to the water molecules, and it is making those water molecules move. It's starting to boil on this side of the pan, while the other side of the pan is not heating up so much. The side of the pan over here, it's heating up, it's expanding, it's rising, and as you watch the oatmeal is moving. The oatmeal is moving. That's the same way we have air particles will move, making wind in another direction. They will move and spread out to the side that is not experiencing the same uneven heating. Gases and liquids are both fluids. Fluid is something that can flow and move around. So as we see that the water with the oatmeal was flowing and moving and flowing and moving, the gases in the atmosphere also flow in the same way. That's it for today, guys. I'm going to leave you some links to explore a little bit more about wind and the solar system. Have a great day.